So 572 is the inspection code. So this is mostly as an inspector, you will be using this the inspection practice, okay, the recommended practice. So this actually tells you the methodology, what to look for, where to look for, that sort of thing. The 510 is the inspection code for pressure vessel, which is based on ASME section 8, right? There is just one section which is a discrepancy between 510 and ASME section 8, and that is about some thickness. So the 510 and 572 are the most important one. And I will tell you, if you study 510 and 572, you would normally pass, even without answering other questions. So this is very important. I'm not telling you to do this, but this is very important. Inspection of relief devices, you receive around 5-6 questions, 4-5 questions at tops, and around 10 questions received from damage mechanism. And damage mechanism is all mentioned here, okay? What sort of damage? You don't need to be a metallurgist or anything, just you should know what is brittle fracture, ductile fracture, erosion, corrosion, that sort of thing, just a basic. But 572 and 510, you have to study intensely, okay? And obviously you have ASME section 8, which is the construction code, and it tells you which one you have to study. So it says UG, which is the general requirement, UW, carbon steel, UCS, UW is welding, and section 9 for WPS, you don't need to be a welding engineer. All you need to know is what is a WPS, what is a PQR, what is a WPQ, and then they might give you some simple question about, if the thickness is this much, the qualifying thickness, so what is the range of qualification, very simple questions they will give you. And then obviously, ASME section 5, non-destructive examination, they tell you article 1267723, which is the general article or radiography, MTPT, and then 23, which is thickness check, UT thickness check, okay? So here, what you should know, the ASME section 8 talks about set the guideline for the procedure, what a procedure should have, what a report should have. So all you need to know is what a report should look like. You do not need to be a welding inspector or coating inspector or NDT examiner to attend this exam, okay? There is no pre-requirement for this. So if you are a coating or welding or NDT inspector, don't read too much into question. The question will be very basic, okay? Now, APA also brought this body of publication effectivity sheet. The body of knowledge. That's we talk about publication effectivity sheet. So if you come here, again, within those documents, if you look at publication effectivity sheet, there is no revision here. They have added 578, positive material identification. This is a new one. So anything in red means the new one, okay? Compared to the previous revision. Now here, they just told you what sort of documents, study material you should study without revision number. And then they're talking about thickness measurement, right? Vessel integrity. They're talking about corrosion rate and inspection interval, right? And they put these things here, API 510 para 7.4. So these are doubly important. Definitely question coming from there. Joint efficiencies. What is RT1, RT2, etc. Definitely there is question coming, okay? Static head, they might ask you, for example, I'm asking you a question. If why we are using this static head here? Why we put the gauge at the highest level? Do you know that?
Actually, I don't know about.
Okay, no worries. It's just that for every 4.33 feet, like 0.4 feet, you got 1 psi increase because of the weight of the water or the liquid or the fluid, right? So if you got a vessel which is 10 feet high, you already got 4 bar difference between the gauge at the top and gauge at the bottom. Okay.
Bottom.
So if you put the gauge at the bottom, so there is and then one put at the top, you get already 4 psi difference here. Okay. So because you see this difference, and we want to do the most difficult, onerous, or as they say technically, so you always put the gauge at the top because you want to measure the least pressure at the worst condition. Like at the test pressure, for example, if your test pressure is say 150, and this is 100 feet, which you get like 40 psi more. So if you got 100 psi at the top, if this is 100 feet, you get 143 at the bottom, the pressure, because of the head of the water. You know, it's the actual pressure plus the head of water. That's why we always say you put the pressure gauge at the top when you are testing it, because that is the least pressure you get. Because you want to go to worst condition, you know?
Yeah.
So you should understand these basic things, you know, you should understand what is the maximum allowable working pressure. See here, calculate total pressure, maximum allowable working pressure plus static head. So you should understand what it is 4.33 is, right? And then UG27, this is not much coming from here. They already mentioned it. You should know very basic what is external pressure, and then UG28, and then pressure testing UG 9900. So these are mentioned in the publication effective sheet. You should study double, right? The joint efficiency, you know, if fillet throat dimension, you know, you have to multiply by 0.7, you know, that sort of thing. Impact testing, you should definitely know. They might give you 3 answers, you know, which one is the possible, you know, is acceptable, the Sharpie test. And then obviously there will be open book question. Then nozzle reinforcement, these are, you don't need to know, they just put it there so to make sure that you understand. You do not need to study this, okay? So what I would suggest to you is that you should study obviously the right revision of publication effectivity sheet, okay? And the most important here is 510 and 572, and obviously there is ASME section 8, which is a code based on ASME section 8, the API 510, okay? And if you look at the 510 and 572, there is a lot of similarities here. And the other advice I would give you, because they are testing you on a basic level, try to understand the concept, you know, the very basic things. Try to understand the vocabulary, what this means, because they might ask you very simple question. What is the meaning of this? Or what is the meaning of that? You know? Could I make, so don't worry. I mean, if you're on the right track, look, you don't need to study 571 extensively. Obviously, you need to do like 13, 14 damage mechanism, very basic. But 510, 572, you study really good. 576 pressure relieving devices, you should know what is, you know, different types of pressure relieving devices, you know, diaphragm type, you know, governor type, you know, weight loaded, spring loaded. What is the difference between pressure relief and pressure safety valve? That sort of thing you should know. Different types of valves. And then 577 welding inspection and metallurgy, you know, is basic, like what you should do before, after, and during welding, you know, the inspection you should do. 578 PMI, where you use it, how you use it, what are the methods, you know, whether X-ray can detect the carbon or not. It's, you know, very basic things, okay? And ASME section 5, you should know about what is in a procedure, NDT procedure or NDT reports. That's what ASME section 5 tells you. And ASME section 8, which is the basis for API 510. And then section 9 is the welding. This this is a 900 page document, but you only need to study like 20, 30 page, okay? So that's it, WPS, WPQ. They might ask you a very simple question. So, but concentrate on 510, 572. That's the most important one.